Hello, in this video we're going to be discussing volume. So I have a cylinder here, and using calculus to find the area of a cylinder, what we want to do is find the area of each cross-section within this cylinder. So I'm going to take a plane, and I'm going to cut through the cylinder here. And when I do that, you can see that the cross-section being formed is another circle. And so if we find the area of this circle, we find the area of all the circles, then we can find the volume for this cylinder. So what happens when we have a more irregular shape? So at the very top I have an odd looking shape. We can call it sort of like a loaf of bread. It's curvier than that, but we can look at it as such. And so to find the volume of that figure, we'll slice with a plane to find the cross-section. We have some sort of rectangular shape sitting within that. We'll slice it again at the very bottom shape to create a slab with a width of delta x. And so there would be an n number of slabs inside this loaf of bread by creating p number of planes to slice that solid. And what we want to do is create those slabs so that they're lower and lower and lower and lower. We have more and more and more slabs themselves of smaller thickness. So then they are infinitely thin, and basically we have just a bunch of different planes that we have the area of, and we can find or add them up to find the volume. So here's the formula for volume using our calculus. Let capital S be some solid, and it's going to lie in the coordinate plane somewhere between x equals a and x equals b. So our cross-sectional area of our solid in the plane p sub x that goes through x and is perpendicular to the x-axis, and the area of that is a of x. Okay, so the area of our cross-section is a of x. A is a continuous function. Then the volume is our limit as we approach infinity of the sum of all of those areas. Or it's the integral from a to b of our area function. So let's use this to solve the problem. So we want to prove that the volume of this sphere has, with a radius of r, is actually 4/3 pi r cubed. So the way we can do this, we have our cross-section drawn in here, and we'll focus specifically on this cross-section. It's a circle, and we know that the radius is r. So coming from 0, 0, I position this around 0, 0. It has a radius of r to the outside of the sphere. If this is the center of the circle, the distance over is some value of x, and the distance up to that point is some value of y. And by the Pythagorean theorem, we know that x squared plus y squared is equal to r squared. So we want to find the area of this circle, and the area is pi times your radius, which is y squared. And so what is the value of y squared? Well, up here, if I just move the x squared over, y squared is the same thing as r squared minus x squared. And so I can substitute that in for y squared. So the area of this circle as a function of x is pi times r squared minus x squared. Now we want to do the integral of this function, so how far left and right do we have to go? Well, again, these are radii, so we've gone over r units and gone left negative r units. So to find the volume, we're going to do the integral from negative r to r of our area function. So pi times r squared minus x squared dx. Now we can save ourselves some time. We know this function is the same area or volume on the left half as it is on the right half. So I can also look at this as the volume equals 2 integrated from 0 to r of pi times r squared minus x squared times dx. And let's go ahead and evaluate this. So I'll first pull the pi out front. So volume equals 2 pi of our integral evaluated from 0 to r of r squared minus x squared times dx. And so our volume is 2 pi times, and we integrate. R squared is some constant, so it's x times r squared minus 1/3 x cubed evaluated from 0 to r. And so continuing on, our volume is 2 pi times, and we'll plug in r for our x, so it's r cubed, r times r squared makes r cubed, minus 1/3 r cubed, minus, and then when we plug in 0, we're just going to get 0. So that's going to cancel itself out. And if we take r to the third minus 1/3 r cubed, we get 2 pi times 2/3 r cubed. And when we multiply 2 pi times 2/3 r cubed, that is 4/3, the 2 times 2/3, times the pi times r cubed, and there's our volume.